Um, so today is our truly first day of doing numbers. Let me try to move this back into the frame. There we go. So I'm going to call this measures of center and spread. And these will be numerical descriptions of your data. So your assignment for the weekend is to make some histograms and compare some histograms of some data that you've chosen. I'm going to have you add in some numerical summaries of your data, and those numerical summaries I will describe today. Now, some of this stuff should be, I learned this in elementary school, and some of this stuff will be just a slight bit more sophisticated, not a lot. So when we talk about a measure of center, we're talking about where most of my data is. And when you've been looking at those histograms, you'll go, okay, the center looks to be around right here. Now you're looking at that that histogram that was, oops, I can't get my bars and connected together real well. Now you told me, the center looks to be about here. Well, of course, we're going to describe that center with a number, and what do you think that number is going to be called? A mean. A mean. Okay. So if my histogram, if the distribution of my values is symmetric, we will describe the data center as a mean. And if my data is symmetric, if my distribution is symmetric, I will talk about how in general this data is spread out, whether it's very spread out or very compact. I will call that measure standard deviation. Now, you've heard the word mean before, and you probably have an oral definition of mean, but you maybe have never seen a formula for mean. So when I say that I'm looking for the mean of a certain data set, what do I do? What do I do if I'm looking for a mean? Yes. Add all numbers and divide by the number of values. Okay. So in statistics, we will call the mean of a sample of a data set X with a line over the top, better known as X bar. And its formula is to take each value, so we can call them by whatever a letter name we'd want, but we're going to take each value in our data set, number 1, number 2, up to the last value in our data set, which we're going to call number n. So I have n values in my data set, and then we'll divide that by the number of values in my data set. So there is a formula. There's another way of writing that formula, and do you know the symbol that you use? Don't know what that was. Do you know the symbol that you use when you're adding up a bunch of numbers? Sigma. So we use this sigma. And in statistics, we don't always use the little numbers on the top and bottom, but let's kind of review what that means for I equals 1. I start at 1, and I'm going to go all the way up to n. Often in statistics, you're just not going to see those values on the top and the bottom. Of all those numbers, and I'll use my indexer. I'll call that as an I. So I'm going to, that means to sum up x of 1, x of 2, x of 3, all the way up to x of n. And now I got to divide by n. Okay. So let's do this with a small set of numbers. I think I'll use 5 numbers. I have to have a small set of numbers because we're going to do standard deviation with this in just a minute. So we'll do the numbers 2, 7, 7, 9, and I guess I want something fairly symmetric. So 10. So the mean of this data set is obviously 2 plus 7 plus 7 plus 9 plus 11 divided by 5, which is 26 divided by 5. Did I add that right? Sorry, 36 divided by 5, which is 7.2. Okay. So there's my mean. Then the next measure, so the mean of this data set is 7.2. My measure of how spread out this data set is, there are 2 measures. One is the square root of the other. The first measure of spread is called the variance. And it's going to be called, abbreviated as S squared for a sample data set. And the formula for the variance is going to be to take each one of those numbers, subtract off the mean, and square it. And we're going to sum again all these numbers. For however big my data set is, all the way out to x of n minus, whoops, I didn't put a bar over that mean. And then I'm going to average that sum of those squares of their differences. And I'm going to divide not by n, but by n minus 1, because it's a funny kind of estimator. It's maybe we'll get into a little bit later why it's n minus 1 and not n. In shortcut formula, I'm going to write this as x sub I minus x bar squared. That's going to sum all of those up, and you'll notice I'm leaving the I equals 1 to n off of here. Divided by n minus 1, or sometimes people like to write this as 1 over n minus 1 times that sum. Move it up more, coming. Is that good? And so the reason that I write these formulas down for you is not because I feel like it's going to make it any easier to find a standard deviation or a variance. It's because you're going to see these formulas, and I want you to be familiar with the kinds of notations that are used in statistics. Now, this variance is actually of kind of an average distance. These values are from the center. And Alexa at the end of the period. And then the standard deviation and that one we're going to abbreviate S, and that one we'll usually talk about more, although the variance is used more in formulas. It's just going to be the square root of the variance. Or you might see it written as the square root of your variance formula. I'm going to add a new page, and then I'll go back and make sure you can still do that. There we go. Okay, so we'll talk more about standard deviations than we will variances, but just realize that the variance is just the step before you get to square rooting your equation here. The standard deviation and the variance, they're kind of averages. Let me go back to my data set 277911. So I had 5 numbers in my data set, so to get my standard deviation, maybe I'll do my variance first so I don't have to keep writing that square root sign. 1 over 5 minus 1 times, it was 2. 2 minus 7.2 squared plus 7 minus 7.2 squared plus 7 minus 7.2 squared plus 9 minus 7.2 squared plus 11 minus 7.2 squared. And, need to put another parentheses there. So this is 1 over 4 times 2 minus 7.2 squared is approximately is exactly 27.04. 0.2 squared is 0.04. That one's in there twice. 2.2 squared is 4.84. 4.2 squared is 17.64. Okay. So this is 1/4 times that whole sum. Some of you, you get a little time here to catch up with me while I'm throwing these in my calculator. One-fourth times 49.6, which is 12.4. And my standard deviation, the square root of 12.4, is 3.52 approximately. So I'll define in words the standard deviation is an average oops, let me write it out. Distance, each value is from the mean. So if I think of that data set of 2, 7, 7, 9, 11, and I think of how far each one of those numbers is from 7.2, the average distance each one of these is from 7.2 is about 3.5 or 3.52. If that number is really big, then my average distances are really big, then I have a lot of variation in my data. If that number is very small, like 0.001, it might indicate to me that my data is very compact. Okay. Why do you think we did this average in such a strange way? Let's see. Here. Let's go up to here. Any ideas why we did this average by taking each value, subtracting the mean, and then squaring it? Yes. Yeah, we need a positive number every time. And so standard deviation and variance, they're always positive numbers. I wonder what would happen if we didn't square these numbers and summed it. What if we took 2 minus 7.2 plus 7 minus 7.2 plus 7 minus 7.2 plus 9 minus 7.2 plus 11 minus 7.2? 7.2 because that's my mean, and my mean I calculated as 7.2. Okay? I'm going to give you about a minute to do this sum without squaring, and you tell me what happens. What are you getting? 2 minus 7.2 plus 7 minus 7.2 plus 7 minus 7.2 plus 9 minus 7.2 plus 11 minus 7.2. What do you get? I don't know why it keeps asking me this. What do you get? You get 0. If I'm averaging the distances from the center, they're going to average out as 0. So I better do a positive distance from the center instead of a whole number distance from the center. I'm sorry, instead of an integer distance from the center. So I don't sign it. And something that comes up with math students, they ask a bit. Lauren, that would be enough. Why do we square it instead of take the absolute value? Wouldn't that work too? And that one I ask anybody that's taken calculus. Why would you prefer a distribution? Why would you prefer a function to be squared over one that's an absolute value? What do you gain by having something that's, an x squared curve as opposed to an absolute value, which is more like a v, right? What's the issue here with differentiation? Yes. Yeah. The limit here at that vertex point um, is not the same from the left as it is from the right. Nicely done. So that becomes an issue when you build up the theory of statistics. Not much of an issue for you guys because you're not going there. But it ends up making things, you have way too many non-differentiable points if you use absolute value. So the theory was invented using squares instead of absolute value. Although you can certainly do absolute values, and there are some parts of statistics that do. Okay? So do you think that I want you to, every time you go find a standard deviation of, let's say, 100 numbers, do you think I want you to throw them in your calculator just like this? No. No, that would be awful. Do you think your little calculator can do the standard deviations? Yeah. All right, so pull out your little calculators. I'll try to write instructions down in the video as we go. Pull out your little calculator. Do you remember how to enter something in a list? All right. So you hit Stat. You hit the number 1, which is Edit. You look at your list 1. Do you remember how to clear out your list 1 rather than delete it? Okay. So arrow up all the way to the top and then hit a clear. And let's enter the numbers 2, 7, 7, 9, and 11 into your calculator. And make sure I did all my math right. Are you missing list 1? No. Because sometimes people have already done the thing where they deleted the list instead of cleared it. It's real easy to get it back, but... All right. Now I'm going to, those of you with calculators out, are you there? Okay. So now I want you to go back and hit the Stat button again. And then I want you to hit the arrow key and arrow over to the calc part. These are the statistical calculations. And the one you're going to select is going to be number 1, which is one variable stats, 1 var stats. So you hit the 1 or you just hit enter. And then you have to hit enter again because now it's, oops, ENT. Now it's come back on your screen. No, enter, sorry. Okay. Number 1, the very first thing you see is the mean we calculated, which is 7.2. And then you're going to see parts of the interim calculation. And then you're going to see a symbol that says capital S, smaller x, and that is your calculator's abbreviation for standard deviation. It does not give you the variance. You'll have to square that to get the variance. And it gave it to me in quite a few decimal places, 3.346640.
So why do we have to learn all that math?
Why do you have to learn it all? Because you shouldn't just press a button and go, this is the answer. You should know how the calculator does it. But, you know, will I really make you do all that? No, I'm not crazy. I'm a little weird, but I'm not crazy. So There are no rules on the AP exam about how many decimal places you round to. You round to a reasonable number of decimal places. So if my mean is at the tenths, my standard deviation should not be a whole number. It should be at the tenths or the hundredths. You know, you can do the same number of decimal places or one more. So 3.35 is fine for my standard deviation. All right. Now that's what I expect you to do on your homework when you go looking for a center and a measure of spread. Okay? I don't expect you to do it by hand. Now that I prefaced this whole lecture, I said that's if you have a symmetric distribution. Oh, what if your distribution is looking skewed? Different, no, skewed left, skewed right, going to do the same thing. Or if it's a distribution that you can't identify the shape, you'll use these sets of measures. Skewed or other, I'll say. And there are other ways to deal with this. There's other kinds of means that we won't even study. But this will be the other one we'll use if we don't have a symmetric distribution. So if my data is, looking like this, or if my data is looking like this, we use as our center the median. And you probably studied median in elementary school at some point. So the median is defined as the middle value. It is usually abbreviated X with a squiggle line over the top, but the AP syllabus does not use that abbreviation. They will use the abbreviation MED, and that's the abbreviation in your calculator. And I want you to, in your calculator, try to arrow down if you have not, if you haven't done anything else in your calculator. I want you to arrow down and see that the median is listed on your calculator as MED for that data set that you put in. So the 2, 7, 7, 9, 11 has a median of, I see the middle value, 7, and your calculator says the middle value is 7. All right. So that's one of your measures if you use the if you're analyzing a distribution that's not symmetric. We need 2 more values besides the median. We need the 1/4 of your data mark. We need the 1/2 where on both you have at this mark, half of your data is to the left and half of your data is to the right if you put the numbers in order. And that 1/2 mark is called the median. That 50% mark is the median. And we want a mark where you see 3/4 of your data to one side and 1/4 of your data to the other. And the 1/4 mark is called the first quartile. I read this before. In your calculator, it is abbreviated Q1. Sometimes it is abbreviated as LQ for lower quartile. And the mark where 3/4 of your data is lower than that number and 1/4 is higher than that number is the third quartile, because the median was the second quartile. In your calculator, it is called Q3, or in some books, it's called UQ for upper quartile. And my calculator says for this data set, the 1/4 mark is at 4.5. So I'll show you how they get that. They go to the left of the median. We look at all the numbers to the left of the median, so that's 2 and 7, and find the middle number for 2 and 7. And the middle number between 2 and 7, there isn't one, so you take the average. And get 4.5. There are at least 2 other ways to get the first quartile number. So I get the numbers to the left of the median, 2 and 7. I find the center number. There is no center number, so I average the 2 numbers around it. That's the first quartile mark. That's one method for finding the first quartile. So it's not standard through statistics the way to find the first quartile, which is kind of crazy, but stop it. I'll have you fix it in a few minutes here for me. All right, to get the third quartile, my calculator says Q3 is equal to 10. All right, to get that third quartile, I go to the right of the median, and that's the numbers 9 and 11, and I got to find the number right in between those, and that number right in between is 10. Okay, so those are the quartiles. My measure of spread is not standard deviation in this case. My measure of spread is called the interquartile range. No one ever says that because it's kind of a hard word to say. Everybody just calls it the IQR. And the IQR is defined as Q3 minus Q1. So my spread, which is not listed on my calculator, is going to be the Q3 was 10, Q1 was 4.5, so that number is 5.5. My spread is 5.5. I am feeling like that's enough. Let me try to turn this off. Oh, I know how I can do it. I need a print screen. Where is my print screen? Oh, print screen function. Yeah. I can't find my print screen. It's not on here. All right. Gotta get a keyboard.